using scientific notation to describe very large quantities. So we're just, like I said, this should be reviewed because we've done this a couple times on our warm-up. So this shouldn't take us long. Expressing large numbers in scientific notation is fairly simple. We take the decimal that, if it's not there, it's invisible at the back of our number. And we want to make sure that remember, we need it between 1, like we have 2 stipulations. Between 1 and 9, that single digit, and that has to be a base 10. A 10 to a something power. So we need to move our decimal all the way between the 3 and the 8. That's going to be 1, 2, 3, 4, 5 moves. And so we're going to get 3.84 times 10 to the 5th power because we moved 5 times. That's all that scientific notation is. But it's in working with a really large number. So when you hear someone say like 3.4 million, well, they're just getting rid of all the other numbers or whatever, so that they don't have to write it out. So it just makes it sound. Sometimes it even just makes it sound cooler. All right. It is approximately 93 million miles. Express the distance between Earth and the Sun. So million is 6 zeros. So we have 93 million. All right, and so now I need to write this in scientific notation. So 1, 2, 3, 4, 5, 6, 7. We get 9.3 times 10 to the 7th power. And you may sit there going, Mrs. Cartwright, this can't be right. This is too simple. Nope, this is how it works. All right, so another key concept, writing scientific notation in standard form. We're going to move the decimal to the right. So I like to kind of rewrite my decimal so that I have space. I need to do 10 moves. So from where it is, I'm going to go to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so now all of these I'm going to add zeros to. And so we're at 7, 3, 2, 0, 0. The 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, and so this is our number in standard form. Ta-da! It really is that simple. So here are some more examples. Rewrite in standard form. So I'm going to put that 1.37. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which would be right, 6, 7, 8. Yep. And so that's our answer for 1.37 times 10 to the 10th. I wrote the 1.37. I did my placeholders in order to get my standard number. Doing the same thing here, 4.37. I'm going to move it 5 times this time. So 1, 2, 3, 4, 5. That adds 3 zeros. So our answer is 437,000. That's scientific notation. We've got one last example. Let's knock it out. The list below shows the number of bacteria in 4 colonies in a microbiology lab. Estimate each number in scientific notation using a single digit for the first factor. Then determine whether each statement is true or false. So single digit, meaning we're not going to keep everything else. So like I would round this one to 8 times 10 to the 1, 2, 3, 4, 5, 6, 7, 7th power. Why did I make it 8 and not 7.9? Because I'm rounding to that whole number because it said a single digit. So here we would round it to 2 mil times 10 to the 1, 2, 3, 4, 5, 6th power. And here we have 6 times 10 to the 1, 2, 3, 4, 5, 6. 6th power. And 4 times 10 to the 1, 2, 3, 4, 5th power. So we've written them all from standard form to scientific notation. I think scientific notation can be easier to use. Colony A has about 40 times as many bacteria as colony B. Excuse me. That is what we're here to find out. So how to find that out is we're going to take colony A, which is 8 times 10 to the 7th, and we are going to divide it by colony B, which is 2 times 10 to the 6th. I'm going to separate this as 8 divided by 2 times 10 to the 7th divided by 10 to the 6th. So 8 divided by 2 is 4. 7 minus 6 is 1, so we get 10 to the 1st power, which is 10. 4 times 10 is 40. So it is 40 times as many. So this is true. If you're like, but how did you know to divide? What is the opposite of times? Division. So I'm working it backwards. This says colony C has about 30 times as many bacteria as colony B, so we're going to try that one out. C is 6 times 10 to the 6th power. B is still 2 times 10 to the 6th. Split it out, we get 6 divided by 2 times 10 to the 6th divided by 10 to the 6th. So we end up with 3 times 1, which equals 3. So this is false. It's 3 times, not 30 times. And then finally, last one, 2 times 10 to the 6th divided by 4 times 10 to the 5th. Now, I'm thinking of this breakdown in my head as I do this. 2/4 becomes 1/2, which is 0.5, times 10 to the 6 minus 5 is 1. So that's 0.5 times 10, which equals 5. And so colony B has about 5 times as many bacteria as colony D, and the answer to that is true. And we have gone through how to use scientific notation for large quantities to help us out. See you in class. Cartwright out.